connecting to the cloud server. Well, it's recording now. So I'm going to share my screen with you and we can get started. So it's doing this weird thing again. Not that. I'm going to try and do that again. And see what it, there we go. There we go. Let's Sarah, if you know that you can all see that. If you can't, could you let us know?
Yeah, have you
can you see it?
No, are you sharing? Yeah, we can't see it, I don't think. So if you click share and then try the application instead of the Zoom or the desktop, then it usually
it's being a bit peculiar.
It can be a bit odd sometimes.
Let's try that one. Joy?
Ooh, looking more promising. Yeah, that's the one.
Oh, perfect. Fantastic. Excellent, excellent. Right, let us begin. So the periodic table is absolutely crucial for your understanding of science. And so being able to understand what's going on and what it's telling you is really, really important. So we thought we'd start off by just having a look at the different subatomic particles in an atom. There's 5 questions there. I want you to just have a little consider. We will go through the answers shortly. So question 1, what are the subatomic particles in an atom? Question 2, what is the other name for atomic number? Number 3, which particles are in the nucleus of the atom? Which of those subatomic particles make up the mass? And what is a relative atomic mass? Okay, so atomic number and relative atomic mass are different. Right, so subatomic particles in an atom. You have your proton, your neutron, and your electron. Okay, the other name for atomic number is the proton number. Now, the particles that make up the nucleus, now this is really, really important because these are your protons and your neutrons. And for question 4, it's those protons and neutrons that make up an element's mass. So you can always say that the mass of the atom is actually located mainly in the nucleus of an atom. And the relative atomic mass is the number of protons and neutrons together. Okay, now I want you to keep that in your mind as we go through this. We've got some words up there on the right that we're going to be looking at today and over the next few webinars. And what we'll do is we've assigned a task for you to have a look at what those words mean and come up with some definitions. So I'll go through them as we go through this lesson so we don't have to dwell on them here. So our next part. What have we done already? So you should know that the periodic table arranges your elements in groups and periods, thinking back to what Sir did last week. You should be able to describe the work of Mendeleev in the development of the periodic table, as well as Thomson and so forth. Okay, so today we're actually going to be looking at this here. Describe the properties and trends of alkali metals, write equations for the reactions of water, and we're going to touch on how they react with oxygen and chlorine. We're very aware that the students in this group have all different ranges of abilities and are doing foundation and higher papers. So we want to make sure that we cover everything for all of you. And I'll signpost you, I'll let you know where we are in terms of what you need to know. The last bit here, we're going to do a little bit of comparison of our transition metals and group 1. So reminding yourselves then, this here is an atom. Sir, I'm going to see if anyone can quickly identify which atom that is, which type of atom, what's its name. See if they can type it in the Q&A. The first person, let me know and they'll get a shout out.
Sounds like a good plan. I'm just waiting for a few of those to come in. Hold on a second. So we've got one answer just saying the atom.
The atom. Well, yes, thank you. We're off the starting blocks then. It is an atom, yes. Remember, these represent here the electrons. So which atom or which element has 2 electrons in its first shell and 1 electron in its outer shell? So a total of 3 electrons. While that's coming in, I'll quickly go through this.
We have got the correct answer.
We've got the correct answer. Who's it from?
John and Flo. Flo's given it as just the symbol.
That's okay.
So we've got the answers of lithium from John
Lithium.
and Flo.
John and Flo can have an achievement point. Well done, John and Flo.
Yeah.
I'm sure that
I'll
points
write their surnames down.
at some point will mean prizes, maybe not yet, but it's always good to have. So looking at our table here, this is some crucial information. You've got your proton, neutron, and electron. We actually say that the electron contributes very little to the mass, so we actually don't even need a numerical value for GCSE. It's roughly 1/2000th. It's not quite, it's not even quite 1/2000th of the size of a proton and a neutron. That's just rounded to the nearest 1,000. So our protons and our neutrons in the nucleus give our atom its mass. The electron doesn't really contribute. Then we've got these charges. Our protons, proton is positive, and our neutrons are neutral, and then just remember electron is negative. So this here is really important when we start talking about ions and how atoms lose or gain electrons and things like that, okay? So thinking about your periodic table, your larger number is your mass number. That's your relative atomic mass, your protons, and your number of neutrons. Then we've got our symbol, and then you've got your proton number, which is the number of protons, but that's also known as the atomic number. Now, here's another crucial piece of information. This 2 protons here that would have the same amount of electrons. So proton number equals electron number. So we're getting on, we're just reviewing now, so we're not going to dwell on this for too long. I'm going to move on. So this is your best friend when it comes to chemistry, or whether you're doing your combined science, your physics, it doesn't matter. This is like your recipe book for everything. Just combined in different ratios to make different products, okay? So getting to know this is fundamental. And this is the AQA, actual periodic table, that you will get a copy of this in your exam. So it gives you loads and loads of information. We know that group 1, it's shown here. It tells us there's a 1, that's group 1. Group 2, this here are our transition metals. We've got group 3, 4, 5, 6, 7, and as Sir was talking about last week, group 0. Okay, the group 0 elements are special because they've got a full outer shell. Today, we're going to be focusing on this spectacular group here, group 1, aka alkali metals. Now, one of the other things I wanted to mention to you is what the group means. Now, it's really, really crucial that you remember in science, we don't try and trick you. Yeah, we don't try and trick you at all. So we tried to make things easier to understand, in fact. So using our periodic table, our list of ingredients, if you like, for everything, group 1 tells us that there's 1 electron in the outer shell, and we then don't change the pattern. Group 2 then tells us there are 2 electrons in the outer shell, and so forth. And as Sir said last week, group 0 is a bit difficult. I know there were some questions last week as to why it's not group 8, well, because they don't all have 8 electrons in the outer shell, they just have full outer shells. That's the important thing. They're full outer shells and they're stable, because helium has 2 in its outer shell and that it's still full outer shell. Okay, so coming back then to our group 1. I wonder if any of you could tell Sir anything special. The first person to say something special about the group 1 will get a shout out. Do that in the Q&A and I'm going to continue on. So we've got our groups, then we've got our periods. So here's period 1, 2, 3, 4, 5, and so on. The periods, again, another little trick you can use. Tell us how many electron shells that an atom has. So if we go back here, this is lithium. You can tell by looking at it that it's in period 2. Why? Because it's got 2 shells. We know that it's in group 1. Why? Because it's got 1 electron in the outer shell. So our periodic table is this brilliant, useful thing that we will use often. I use it all the time. I don't know every single one of these off by heart. It is helpful to know the first 20 or 30 just to make things easy when you're in exams to consult where they are. So little quiz for you then. Here is our periodic table. We've got our groups here, these vertical going down, vertical. Then we've got our periods, which are the horizontal lines. So I can't see what I've written here. I'm hoping that you can. I don't know if I can even move that. Can I move that? Oh, I can move my head. There we go. Which element is in group 2? So we look along here. Here's group 2, period 3. 1, 2, 3. and that is here. Magnesium. I'm going to give you a moment to just quiz yourselves on which element is in group 1, and then you want to find period 4. One of the ones we'll be looking at today. Just keeping an eye on the time. And then which element is in group 0, over here, period 5. And then which element is in group 5, period 3. I'll just give you a moment to have a look and see if you are able to do that. That helps us to remember. The group tells us how many electrons are in the outer shell, and the period tells us how many shells. So we're just doing these little tasks to try and just familiarise ourselves a bit more. So group 1, period 4 is potassium. Group 0, period 5 is xenon. And group 5, period 3 is arsenic. Moving on.
We've got a few good answers in the chat there and question Q&A there as well, Miss. So,
okay, who are we going to shout out to?
Actually, I can't, because one of them, it'd be nice to know who the anonymous viewer is. This is also another plug as to why it's important to sign up with your names, guys, so that we can actually then, you know, go on and give you achievement points and those kind of things, as well as obviously the wondrous praise from Miss Tomlinson.
Oh, they're missing out.
Yeah, they are, aren't they?
It's a shame. See, there we go. Right, we'll see if that person decides to tell us who they are, and we can give them an achievement point. So, the alkali metals. Now, if you haven't seen these in class, then I don't know where you've been, okay? So our group 1 metals, these alkali metals, are in the furthest group left on the periodic table, and they're called alkali metals. So here they are: lithium, sodium, potassium, rubidium, and so forth. They're in this column here. And you will have seen them because they produce some pretty explosive, if you like, reactions. And we show some of them in class, only lithium, sodium, and potassium. And we'll explain why you don't do the other ones in a minute. Now, because they're so reactive, we rarely find them in nature in their elemental form. They combine with other things, okay, because they're just so reactive, they've reacted with them. So I have some questions for you. Don't need you to answer these, okay? These don't need to be answers. So I want you to keep these questions in your mind. I want you to think about how many electrons the alkali metals have in their outermost shell. And remember, they're in group 1. I want you to think about the reaction with water as we go down the group and why that you think that is. I'm going to throw another question to think about in there as well. If they react that way with water, can you think or predict how they might react with other substances as well as we go down that group? Okay, so in your class, if you've been in my class, I'm pretty sure if you were in my year 8 class last year or year 7 the year before, we would have done the alkali metals. And you would know that they're stored in oil to stop oxygen from the air reacting with those metals. Remember, they react very quickly, so they tarnish, okay? And these metals also react with water to form metal hydroxides and hydrogen gas. Now, we're starting to give you some really important information here. This idea that they form with water, react with water rather, to produce metal hydroxides and hydrogen gas. This is a fundamental piece of information. I'm not going to leave it there. I'm going to keep bringing that up as we go through this webinar. Another question for you. No tricks in science. They're called the alkali metals. What colour would they turn universal indicator? We're not tricking you. Think back to all those fancy experiments you did in year 7, putting universal indicator into juice or toothpaste or bleach or cleaning products. What colour were the alkali products? Those with that OH minus. Have a little think. I'm sure Sir will tell me about one of you getting it right in a minute. So, while you're doing your answering and whatnot, I thought it'd be nice to show you a clip. I was going to show you Miss McGinley, but I think the clip we did is a bit long. It's about 9 minutes, and this one's much shorter. So I'm going to show you this kind of 3.5 minute clip now. We'll also save it to your Google Classrooms for you as well, so you can watch it then, just to remind you of how spectacular science is and how we can't wait to be back in the classroom doing laboratory, doing these things with you. So let's have a little look at this. I'll try and maximize it for you so you can see it.
Group 1 of the periodic table is a group of reactive metals. Lithium, sodium, and potassium are at the top. These metals are so reactive, they have to be stored under oil and need to be handled with care. Lithium is so soft, it can be cut with a knife. You can see how shiny the freshly cut surface is. But leave it exposed to the air for a few seconds, and it quickly begins to tarnish. It's reacting with the air. This is sodium. It's even easier to cut, and again the shiny surface soon discolors. Potassium is even softer and reacts so quickly it tarnishes immediately. Another way of comparing reactivity is to place the metals in water. Lithium floats. It reacts immediately, fizzing and skating around on the water, which is evidence that a gas is being produced. By carefully putting a tiny amount into a boiling tube, the gas can be tested with a lit splint. A squeaky pop means it's hydrogen. Universal indicator shows that at the end of the reaction, the solution is alkaline. Lithium reacts with water to form lithium hydroxide and hydrogen. So how does sodium react? Again, it floats on the water and fizzes. The gas produced is hydrogen. And the solution is alkaline. When sodium reacts with water, sodium hydroxide and hydrogen are formed. Sodium is more reactive than lithium. It's below lithium in the periodic table. Potassium is below sodium. So how would you expect potassium to behave? Potassium is definitely more reactive than sodium and lithium. It reacts immediately, and the hydrogen produced ignites on its own. Universal indicator goes blue. Potassium reacts with water to form potassium hydroxide and hydrogen. Rubidium and cesium are elements which lie below potassium in the periodic table. How would you expect rubidium and cesium to react with water?
Lovely video.
Right, fantastic.
So we just to jump in very quickly, as you asked for a couple of answers, we did get some answers about the universal indicator. A couple of them coming in before the video
Brilliant.
there, which is really good. So we got one again from an anonymous user who I asked for the name, and there's another one from Sky, who came in with the correct answer there. First, actually telling me red and then saying joke. It's purple.
Oh, we don't do jokes in science.
Yes, exactly. It's just leading me down the wrong line. And yeah, so there was one from Sky and one anonymous user. So again, guys, you're going to have to make sure that you take off that anonymous viewer or write your name at the start of the comment. Otherwise, we won't know.
Exactly.
But yeah,
Right.
then came Jimmy shouting purple afterwards after we'd seen it on the video. But good stuff.
Brilliant. This is fantastic. So you would have seen from the clip that there are particular properties that alkali metals have. So they're soft, you can cut them with a knife. They have low density. The first three in group 1, alkali metals, can actually float on water, and they have low melting and boiling points. That makes them a bit different from your normal metals, but they do have some other properties they share, which is good conductors of heat and electricity, and they're shiny before they react with oxygen in the air. We wouldn't use them to in electrical cables or anything like that because they're reactive and we couldn't. Okay, so that would be a reason why you can't. So what are the trends in density? So we like a good pattern in science. So there are our group 1 elements. And as you can see, as you go down the group, they become more dense, apart from potassium here, okay, which it throws a little spanner in the works. But apart from potassium, the density increases. And this means that some of them are so, their density so low that they can float on water. So if water has a density of 1 gram per decimeter cubed, which 3 of these will float? And it's the top 3 because it's less than 1. Their densities are less than 1. So the trends in melting and boiling point. Melting is the point in which the solid turns to a liquid, or molten in this case. And the boiling point is that transition to a gas vapor. So you can see that as you go down the group, both the melting point and boiling points decrease. They get smaller. Notice this language in science. We don't go, they get less or they get smaller. We say that they decrease. That word is so important, using the term decrease. That's how you get marks in the exams, okay? So here, if you look at your cesium, that's got very low melting point. That'd melt in England on a particularly hot summer's day. Okay, so just remembering these patterns here, the melting and boiling points decrease as you go down group 1. And the reasoning behind this, and if you are pushing for that grade 4, grade 5 and above, you need to be able to explain why that is. And that's because the actual atoms get larger, okay? They've only got 1 electron in their outer shell, and as that gets further away from the nucleus, it means that less energy is required for these changes. So very quickly, our electron structure. So here we have our first 3 atoms, lithium, sodium and potassium. In the exams, they're not going to have you drawing out millions and millions of shells. Okay, that's an exaggeration, there aren't millions, but I think by the time you get to potassium, you'd be drawing enough in the exam. So the first 3 are the ones that we've put here. Lithium, very common to draw, as is sodium, okay? Lithium, 2 electrons in the outer shell and 1 in the shell and 1 in the outer shell. Notice they all have 1 electron in the outer shell. That is something that makes them similar, their properties similar. And they can get this full outer shell, which is what they want to do. They want to be like the noble gases. They want to be stable, which is meaning that they have a full outer shell. And they can do that because it's relatively easy to lose this 1 electron. Now, when they lose this electron, they become an ion. Ions are charged particles, okay? And they are positive ions because if you remember, our atoms are neutral. If you think about a weighing scales or a balance, the old-fashioned ones where you put a lump of mass on one side and a lump on the other and they balance out, think about that in terms of our protons and our electrons. They balance each other out. If you take away 1 electron, it means there's 1 more proton than there is electron, so they become positively charged. So our group 1 metals form positive ions with a +1, that positive 1 charge, okay? The loss of 1 electron gives you a positive 1 charge. Okay, and we know that they have similar physical and chemical properties. So as you go down the group, the reactivity increases. Okay, the electron in the outer shell gets further away from the nucleus because there's more shells. Okay, they're shielded, if you think of it like a shield, and it's electron shielding. And remember, our protons are positive and our electrons are negative, and those are the things, those forces attract each other. If that electron's getting further and further away from our positive proton, then it's much easier to lose that electron because the forces are weaker. So reactivity increases with the size of the atom because that outer electron is further away from the nucleus. Stuff to remember. So we've had a little look at this. This is just a summary. That will be in the PowerPoint slides that have been given to you in your Google Classroom. So reacting with water. So we've seen from our little clip that if you put alkali metals into water, they react, okay? Now, alkali metals plus water give you an alkali metal hydroxide and hydrogen, okay? I wonder if I can move that back. So it's not, I don't even know if you can see that in the way so much. Okay, so you all, whatever paper you are doing, foundation or higher, need to know the word equation, okay? You all need to know what the products are, okay? This is also an exothermic reaction, so it produces lots and lots of heat when the reaction occurs, okay? So some of you will also need to know, the majority of you will need to know the balanced symbol equation, which is here, okay? Now, I said there's a pattern to this, so let's start with the pattern of our word equations. Any alkali metal plus water will give you that alkali metal hydroxide plus hydrogen, and this G here means gas, okay? And so I'm going to ask them to tell you how to check for hydrogen gas as I go on, okay? This will all be in summary. You can rewatch this, pause it, and we've shared the slides with you as well, okay? So you don't need to take notes at the moment, just make sure you're listening. What can we do to check for hydrogen gas? And Sarah will let me know who the first answer is. So what happens when we react with water? Now, what goes into a reaction must come out, okay? You can't have extra things come out because they weren't there in the first place. What happens is there's a rearrangement and we get different products, okay? So the alkali metals react vigorously with water. The ions present in the alkalis, this OH minus group, help to make it alkali. That's what makes it alkali. So we've got our gas, the hydrogen gas. Where does the hydrogen come from? All you've done is react the alkali metal, whether it's your Li or your Na, with the water. And you think, so where does the hydrogen come from? Well, the hydrogen comes from the water, H2O. There's hydrogen in the water, okay? As you add your universal indicator, it turns purple to let us know that they're alkali. Remember, no tricks. So lithium, our least reactive metal, we saw from the clip, fizzes. These are observations you can make to let you know a reaction is occurring. And these are really important as well. In the exams and things, you might be asked, well, how do you know the reaction has taken place? You can say, well, we can tell a gas is being produced because it's fizzing, okay? And so here we've got lithium. Oh, this has come out of sync a little bit, but I'll talk you through it. Lithium plus water gives you lithium hydroxide, LiOH here, plus hydrogen. So did we get an answer for the hydrogen gas, how to detect it?
No, we didn't for that one, I'm afraid, miss.
Really? This
Yes.
is practical. They love doing it. So much fun.
I know. Yeah, I was trying to also give a hint of the fact that it came up in the video as well. We did see with the tests in the video, but I haven't seen one with the correct answer yet, I'm afraid.
Well, I'll keep waiting.
Yeah, okay. So I'll keep handing out a few hints.
Thank you, sir. So lithium plus water gives you lithium hydroxide and hydrogen gas. It's similar. If you have sodium plus water, you get sodium hydroxide and hydrogen gas. It's the same for all of our group 1 elements. So this one nicely has actually stayed in sync. So sodium fizzes more than lithium. That's evidence that it reacts more vigorously. Notice that word, vigorously. It actually melts and becomes spherical like a ball. If you think about those 3-dimensional shapes you had to learn when you were like 9, it becomes spherical. It becomes a ball. And occasionally you'll get a flame because there's so much energy that the hydrogen, heat energy, that the hydrogen ignites. And so here we have a look here. You've got your alkali metal here, which is sodium, and your water. You get your sodium hydroxide. That's that OH group making it a hydroxide. And if it's high and ox, you know it's H and O, hydroxide. I'm not tricking you again, thinking about that. And hydrogen gas. Okay. And so it should come as no surprise to you then that when you add potassium and water, you get potassium hydroxide and hydrogen gas. And this is one that's most spectacular in class. You're like, do a bigger bit, miss, or sir, make it a bit bigger. We can't, it's dangerous. We don't want to set fire to anybody's eyebrows, okay? So potassium plus water gives you potassium hydroxide and hydrogen gas. Now, you do need to be able to balance these equations for those of you who are going really for a 5 and above. But the things that will help you to guide in what your products are, you know it's a hydroxide, so it must be an OH group and it's going to have the metal, okay? And if you think about what's in the water and how they're bonded together, which we will be doing, and how those bonds can rearrange, we'll talk about that as well later on. So just keeping this in mind, okay? So those of you who are going for sixes will definitely need to know the symbol equations for oxygen as well with an alkali metal. Those of you who are going for 4 and 5, for the oxygen ones, it tends to only be the word equations. So alkali metal plus oxygen, so that's foundation paper, gives you an alkali metal oxide. Again, no tricks. So lithium plus oxygen gives you lithium oxide. Sodium plus oxygen gives you sodium oxide. What must potassium and oxygen get? You guessed it, potassium oxide. Okay. This is very spectacular, this demonstration, if you were able to see it at school or in a clip.
So
I actually, sir?
Sorry to jump in. I did get a couple of correct answers from the previous question about how to for hydrogen. The first in was from Sam Noak, who came straight out with the squeaky pop test. So
Fabulous.
he described it well. And then we got Sky talking about it makes a pop. So, you know, that's pretty close. You just need to talk about, obviously, the lit splint. And then with Maya as well coming in with a similar answer. So, yeah, a few good answers coming in there. Sorry to jump in.
Fabulous. I'm loving this, that you are actually interacting. That's what Sarah and I want. We want you to kind of be on this journey with us. This is like being in class, like, kind of, but not, but we are.
Yeah, it's lovely to be able to sort of close that dialogue or to answer your questions now. And this is also the benefit, as we were saying last week, Miss, of doing the webinars live. So, you know, rather than watching them on the YouTube links, if you watch them now, you can ask questions and Miss and I can answer them there and then.
Exactly. So it's fantastic. So get all your friends next week. We want to see more of you. Okay. So I'll just mention at this point, remember the G is for gas, therefore the S is for solid. If you see L, it's a liquid, and AQ is aqueous. That's a solution. So something dissolved in a solvent. Right. Oh, look. Oh, this has gone a bit wonky. In your PowerPoint, it's fine. So we're going to almost end, I think. I can't remember what time this finishes, but let's do this exam question. So I'm going to move my face again so I can see it properly. So lithium is in group 1 of the periodic table. It reacts with water to produce a gas and an alkaline solution. So it's even showing you the picture. This is water, lithium, and bubbles of gas. And notice here, this is across the papers. So this would be on the foundation paper and the higher paper. Okay, so that's why we put this one in here. So it says, firstly, name the gas produced. And I would hope now all 60, some of you have disappeared, 65 that are still here would be able to name that gas. Okay, so I'm going to wait and Sir can tell me the first person to name the gas. And then which ion causes the solution to be alkaline? Now, I just mentioned those several times in the past couple of slides. So I want you to think about that. And potassium is also in group 1 of the periodic table, and it reacts with water in a similar way to lithium. And it says here, being specific, no more, no less, write down 2 differences you would see between the reactions of potassium and lithium with water. So, Sir, did we get any answers for that gas?
We did. We got Sky and Maya in straight away in as the first answer. Sky's was just a minute earlier of hydrogen.
Brilliant. And have we had any answers for the ion?
Not quite yet, no.
Remember what we said? In fact, I'll flip back. So we know that they are alkalis. Let's quickly go back because it's with water. We know that they are alkalis. Which thing in the word equation here makes it alkaline? Which ion, so which charged particle here, I don't know why I'm swirling my pen there because you can't see it here, rather, makes it an alkali. Okay, so potassium hydroxide. I can see John raised his hand and I taught John this. So I'm hoping that John actually knows the answer.
So I've got an answer from Anifa. She's saying lithium hydroxide. So she's so close.
So close, but
yeah, take away the metal there, really, doesn't she? And then she's got the ion.
Anybody come back with the ion?
No, sadly not quite yet. Sky's also answered just the metal, potassium. So we're looking for the other bit, not
the
lithium.
Other bit. So you're having a great go. That's fantastic.
Yeah, it's lovely to see your answer.
Let me put the first answer. So we knew the gas was hydrogen, and then the Ion is our OH minus. It's OH minus for our alkalis, and then we've got H plus for our acids, just throwing that in there. Okay, so write down 2 differences you would see. We're not going to ask you to do this now. I want you to just think about it. So it's really, you can be really specific. Potassium would fizz more as it gives off more gas. Potassium reacts more vigorously than lithium. Noticing that word vigorously, more gas, fizzing, okay? And so that's that. That would be the full 4 marks for that question that straddles both the foundation paper and the higher paper. So very briefly then, you should have come across this in years 7 and 8, I do believe. If you look here, just the first 3, we're not going to go too far on this. We know the names of the elements. The structure here is telling us that there's 2 electrons in the first shell and 1 in the outer shell. Notice that that is the same for all of those. And then it's slightly different for our ion because we lose this electron. If we lose the electron, the atom is no longer an atom, but it is an ion, a charged particle. And we draw that by putting these brackets around. And in your exams, you'll usually only be asked to draw the outer shell, okay? And this plus here means something. I'm just going to give you a brief moment just to think about what that plus, that positive symbol, it's not an add, it's a positive symbol, what that means.
Also,
what has
just noticed
happened?
your mouse looks just like one of your subatomic particles there, your cursor as well, doesn't it? Actually?
It does, sorry. It was all planned just to fit the scheme. I'm just going to leave that over here then. Oh, look.
Yeah, true. Yeah, if you put it on.
No,
That's
it's lost.
Oh.
It comes here.
Stealthy Electron.
So we talked about the ease with which the group 1 alkali metals give away this outer electron. They all want to be stable. In order to be stable, they have to have a full outer shell. So they're like, oh, great, I'm just going to get rid of this. I'm finding it quite easy. I'm going to give it away, and then I'll be stable. So this lithium here is giving it away, okay? If you start thinking about bonding, it's giving it away to something else, okay? They don't just disappear off forever. It's donated it, giving it away. So it's now stable, but it's still got the same number of protons as a lithium. So it's still lithium. It just is now a charged particle. So it's a lithium ion. This plus, this positive symbol, it may even have a 1 next to it, means that it has positive 1. Its charge is positive 1. This just means that there is 1 more proton than there is electrons. That's those scales, that balance. We've lost 1 electron, and so there's 1 more proton, so it's plus 1. If an atom, not in group 1, perhaps in group 2, lost 2 electrons, what charge do you think it would have? What charge? I'm going to see if anybody comes up with that in the group there.
Yeah, we've already got the right answer from Maya. She's getting some fantastic answers today, Maya.
On fire, fantastic.
Yeah, on fire. Jimmy's given a correct answer, but it's not the exact charge.
Has he just given the numerical value?
No, he's just given the positive or negative charge.
Oh, right, okay, but you are right, and it's positive.
He is
Jimmy.
correct, he is. Yep, that's correct.
This is fantastic. I am not going to focus on this too much. I think you've had enough, and we'll go over this a bit next week. This all kind of links into our bonding, and we'll be looking at that more when we look at group 7, because group 7 and group 1 have a very, very special relationship, which Sarah and I will go into. In your PowerPoint, you'll have this. Have a go at these questions. The answers are there too, so you can see what you've got. So why are they called the alkali metals? It becomes quite obvious, so you can have a look at that. Then explain the increase in reactivity. So these are and the next question here is your highest question. So have a look at that as well, but we won't go through that now. Have a look for yourself. So this is the stuff that's a bit more challenging, but we'll go into more detail on that next week. And this is for your kind of grade 6 and up now, okay? We'll do a quick poll and then we'll end, if I can remember how to do a poll. So let me stop sharing and we will do a poll. And not that one. we will do that one. So I'm going to launch polling, and I'll give you, I think it's 5 questions, 6 questions. You can start. And see what happens.
Yeah, great stuff there, Miss. Very good.
Thank you. I realised, guys, there's a lot in here, and we were actually going to do double the amount, but realised perhaps that we needed to slow it down a bit. We don't want to go too quickly, and I think it's really important, especially as you're working at home, that we can keep it in chunks, and we'll just keep learning every week until we feel that we're ready for the next topic.
Yeah, definitely.
So the polls are coming in. We'll give another 20 seconds. Another 20 seconds, and then hopefully I can do that now. So what does the group tell us? Fantastic. The majority of you have told us the number of electrons in the outermost electron shell. What colour do the alkali metals turn universal indicator? 86% of you have got that correct. That's brilliant. What is an ion? A charged particle. Even better, 95% of the correct answer. What charge do group 1 ions have? 73% of you have answered that correctly at +1. Okay. And question 5, what do alkali metals produce when they react with water? We've got 50% of you saying alkali metal hydroxide and hydrogen gas. And there's I see some of you've said hydrogen gas. That wouldn't be wrong. Actually, that wouldn't be wrong, and that's 17%. But I wanted both, so that's my fault with the poll. I perhaps wasn't as clear there. So we will end that polling. Thank you very much, Year 9. So for all of our questions, the majority of you have got those answers correct. I think we will go back over the alkali metals and what they produce when they react with water. But that's it. So thank you very much. And Sarah and I will see you here next week.
Thank you, Miss.
The instructions for your work are on the end of the slide as well. Okay. And there's some extra clips for you to watch if you found it tricky or you want more work in preparation for next week. Thanks.
Thank you very much, Miss. See you later.
Thanks, cheers. Bye.
Bye.